Where else can 19 go? Good. So 19 automatically without even like thinking too much. You should have put 19 there. And then you have 34 here. If you split that, what's each of those little pieces? Good. So 17 and 17. And then you have two numbers on the inside. What we talked about yesterday was from the vertex to the center, vertex to the center, vertex to the center creates the circumcenter. All of those hypotenuses are congruent. So which number could I actually move around? The 15 or the 21? 21. So 21 could go here, 21 could go here. Can the 15 go anywhere else? No, because that's a height and all the heights are different. So if I want to find TU, what is 19 times 2? 38, because like you just add them. Okay. For V to Y, 17, because I cut it in half. U to Z, 21. 21. Okay, this one we have to Pythagorean theorem our lives away. So yes, you would get, I'm pretty sure 14.7, but let's look at it. You have WV, which is here, which there's no number, so you would have to Pythagorean theorem your triangle. So 21, 15. So I'm not going to do it for you, but I'll write out the problem because this will be on your test next week. So 15 squared is one of your sides. 21 squared, that is your C. So whenever you use the Pythagorean theorem to find one of the legs, you square it, you subtract it, and then you square root it. So you get 14, what did we say, 14.7? So 14.7. And then for the last one, you have to find T to V. Where's T to V? Oh, that's that whole length. So if this is 14.7, what's the whole length? Yes, 29.4, because it represents the whole distance. Okay, today we are going to do incenters. So yesterday we did circumcenters. This was like worse than incenters. A lot of people today are like incenters are way better than circumcenters, just so you know. So if you were lost in the sauce yesterday, today should be better. The only thing I do want to add to yesterday's notes are where you have the circumcenter written up here, I want you to write congruent hypotenuses. Hypotenuses. I don't even know if that's a real word, but it's multiple hypotenuses. So these are congruent hypotenuses. The only thing that was not congruent on yesterday's picture was the actual height of the triangle. Today it's going to change. Yesterday also on circumcenters, the sides split in half, so they were congruent. Today that's also going to change. So let's go to the in-center side. Hopefully you have two colored pencils so that way you can like exchange with your little neighbor. So for an in-center, this is actually created by angle bisectors. Yesterday it was a perpendicular bisector, so it made a right angle and was perpendicular and bisecting, cutting it in half. Now it's an angle bisector, so the angles are splitting in half. The incenter is always equidistant from the base of the triangle. So it is not the hypotenuses that are congruent. I want you to pick a color, and we're going to say from P to F is congruent. P to E is congruent, and P to D is congruent. So if you look at your hypotenuses today, this hypotenuse, AP, is definitely longer than this side, P to C. That one's definitely shorter, so they are not congruent. Now it's the height that's congruent. So we're going to list the angle bisectors. So we're looking at the angles. We're looking for something that's cutting it in half. So if I say AP is an example of the first one from A to P, what's another angle bisector? What did you say? P, not E. PC is one because it's splitting the angle in half. And then P to B is the other one because they're splitting the angles in half. So angle bisectors. The incenter is labeled by what letter again? P, because it's right in the center. It's just a different type of center. And then all the congruent segments, now it's going to change. Yesterday, this base would have been split in half, but now we can use common sense and look at this and say, those are not equal. They're not the same. So what it's actually doing is AF is congruent to what other piece do you think? AD. So now this is what you guys were trying to do yesterday, is match those sides. A to D. So pick a color. Same thing, I'm going to go to a different angle bisector or a different angle. If I say DB is congruent to something, what is D to B congruent to? B to E. Bless you. So I'm going to pick a different color. Those are going to be here. And then the last ones are going to be those last two. I could say FC is congruent to what? What'd you say? C to E. Nice. And then use your last color. So start exchanging with your neighbors. Or make like a cumulative pile in the middle. Okay. So now the sides are congruent where the angle is actually being formed. So these are congruent, and these are congruent. And then the height is congruent. The hypotenuses are not today. And because we're talking about angle bisectors, we're probably going to be talking about angles too. So we're talking about the insides of a triangle. So let's go down to number 2. And let's move around what we can. So let's look at our picture for number 2. Where can the 6 also go? BF, okay, because those look the same size. That makes sense. Let's go around the outside. 35, where else can that go? FC, so 35 can go up here. There's nothing else around the triangle, so let's look inside. We have a 37. Can that 37 go anywhere else? No, because using your eyeballs, that is way longer than any of these other lengths because it's a hypotenuse. The part that's actually congruent, I want you to pick a color, is the perpendicular parts, the height of the triangle, what's meeting with the actual base of the triangle. So all of those, whatever, if I knew one was 10, then all 3 of those lines would be 10. So let's fill out what we can. So G to D, do I have a number already there? No. How could I find that length or the height of the triangle? Pythagoras, he's back. La 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 la. Okay, so we're gonna make a Pythagorean theorem problem. 35 is the bottom. 37 is the hypotenuse. I'm trying to find either A or B. So take a second. Yes, let people think though. Because they're going to have to do it on their test too. You're just so fast. Fast like lightning. So square your numbers, subtract the 35 to both sides, and then square root it. So you should be taking the square root of 144, so you should get 12. So 12 is there. Where else can 12 go? FG, and where else? EG, because they're all those little blue lines, so all the heights of the triangle are actually going to be the same. So 12, 12, 12, 12, 12. So GD is 12. What about B to G? Is there a number there? No, so what are we going to have to do? Pythagorean theorem. So it doesn't matter which side you use because technically the triangles are congruent. You have 16 or 6 and then you have 12. You have 6 and 12. So it doesn't really matter which side you use because now we got to find B to G. So we need to find this part, the hypotenuse. So we're going to find C, which is really nice because this one will be easy to type into your calculator. This is not a subtracting one. The bottom of the triangle is 6. The height is 12. You're trying to find the diagonal. So you can literally just type this into your calculator like all at once. You could do 6 to the power of 2 plus 12 to the power of 2. Press equals, and then square root that number to find the hypotenuse. Does anybody know what we get? 13.4. And then what's FC? That one's easy, 35. And then BF, 6. Let's do another one. Let's go down to number 3. So take a second. This triangle does not have any numbers. You're going to have to put the information in your picture. So try to figure out where this stuff goes in your picture. Hopefully you're using a pencil, just in case you put it in the wrong spot. Yeah, just bring me your phone. Take the pass. And be fast. Just put it right there. Okay, if it says PRQ, M means measure, the measure of PRQ. PRQ, people are like, it's 180. That's the whole triangle, but this means the angle. So this is literally just R. Okay, so this whole angle right here, PRQ, that whole thing is 8x minus 10. Then you have the measure of RPQ. That whole thing is 4x minus 14. Then you have PQR. PQR, this whole thing is 7x minus 5. To do what? Oh my God, you're a genius. Why? Heck yeah. So this thing, even though it has a bunch of little triangles in it, it's actually like a big triangle as well. So we could take all of the angles, we can add to make 180. I'm going to use the space down here just because like there's a bunch of space. So for 4x minus 14 plus 7x minus 5 plus 8x minus 10 equals 180. So even if the equation ends up like super long like this, it's going to reduce to a 2-step equation. So add all your x's, add all your numbers. If you combine your x's, what do you get? 19. So we have 19x. And then if I combine all my numbers, what do I get? Negative 29. So minus 29. And that equals 180. So if you solve your 2-step equation, you add 29 and you divide by 19, what do you get? X equals 11. Now, what are we probably going to have to do? Plug it in. So you don't have to show the work for this. You can do it in the calculator. If this angle is 4x minus 14 and you're taking 11, you're substituting it back in. 4 multiplied by 11 is how much? 44. 44 minus 14 is 30. So that whole angle is 30 degrees. If I go over here to Q, it says 7 times 11. 77. What's 77 minus 5? So that whole angle is 72 degrees. And then down here, you have 8 times 11, which is 88. 88 minus 10 is how much? What? 78. Okay, so now let's see what we can have, or like what we can find. The measure of PRQ, 78. The measure of RPQ, 30. The measure of PQR, 72. And then you're like, we're out of numbers. So here we go. This is where it gets interesting. Now, a lot of people still don't know how to read these. Yes, it's the middle letter, but you have to look at the other letters to know which direction it's going. You want to know R to P to S. So you want to know this angle right here, R to P to S. What is that little slice going to be? Yeah, because it's an angle bisector. So this angle is 15, which means the other side's 15. So RP to S is cutting it in half, so that's 15 degrees. That's why they use 3 letters to represent an angle instead of just 1 letter, because technically P has 3 directions it could go. It could be the whole angle, it could be this side, or it could be that side. So then let's do the next one. It says PQS. So P to Q, I'm ending at S once again. So it's cutting it in half. It's this little tiny angle. 36, because I'm dividing by 2. So this side's 36 and this side's 36. And then the next one wants to do PRS. PRS is this piece of pie. 39 and 39. And now we have one leftover one, and you're like, God, I wish this would end. So now we need PSR. So if I start at or P, I go to S and I end at R, I'm talking about this right here. Does anybody know how I could find that angle right there? No. To make what? Yes, because even though this whole thing is a big triangle, you also have this cute little tiny one right here. So this whole triangle right here needs to also make 180. So to find S, you're going to add them and subtract it from 180. So what is that angle right there? 126. Well, because semester 1 is easy because like it's like building on all these weird little concepts, and then like semester 2 is like, okay, now let's apply everything like in the same problem. Because this makes a triangle, so basically you have like your own little triangle. I'll try to draw it. This angle's 15, this angle's 39. You're trying to find that guy, the last guy, so you're adding to make 180. Isn't that, aren't you the one who told me how to do it? Anyways, so a triangle makes 180, so that last angle would be 126 degrees. Do we like today's better than yesterday's? We don't like any of it? We're loving math class right now. We're having a great time. Everything's fine. Okay, let's go to the last problem we're going to do together. Let's go on the back. Let's go to number 19. So 19, same idea. I want you to look at your picture and move around things first. So take a second, see what matches, where you can move things for number 19. Yep, try number 19. Move around your angles, move around your little things. The next like 2 weeks of math is like a puzzle. Okay, so you should have like that. 19 can go on the other side, 27 can go on the other side, 17x minus 7 can go on the other side. So now what must we do if we're trying to find x? Okay, so if you equal these to each other, they're the same exact thing. So if you add 7 to both sides, it's going to cancel. If you subtract 17 to both sides, it's going to cancel, and x can't be nothing. Times what? What do you mean? Times what by 2? Just this? No. Yeah. Huh? What'd you say? Yes. So Yes, because the whole thing represents a triangle, right? So even though we have like a bunch of little individual triangles, we're not including the 90s. We don't really care about them, but the vertices right here and right here, those are all going to add to make 180. So each corner of triangle. Now you have double, so you could either make one really long obnoxious equation, this plus 27 plus 27 plus 19 plus 19, and then equal to 180, or you could just multiply by 2. So if you do 2 times 17x minus 7, and then you're adding 2 times 27 and adding 2 times 19. Oh, crap. Let me zoom out. Equals 180. Because you have 2 of each angle because they're bisectors. So distribute, multiply. What do we end up getting? Should be x equals 3. Should go out evenly, right? Yeah. And then this one we don't have to plug back in because it says find x. Today, when you're working on these, they're not as bad as yesterday. So if you gave up on me yesterday, don't give up on me today. They're not terrible, I promise. Let me know when you get stuck, because it's probably going to happen. But that's okay. Better you stuck now than during the test. Okay.